Welcome to Tech with Kaushik. This is part 11 of our complete practice question series for the SAA-C03 AWS Certified Solutions Architect Associate exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 11. Question number 361. A public sector portal runs on EC2 instances behind an internet-facing application load balancer. Users experience intermittent slowdowns during distributed denial-of-service events whose apparent source addresses change continuously. The security team wants enhanced attack reporting and access to AWS specialists without redesigning the application. Which solution should be selected? Option A. Place an Amazon CloudFront distribution in front of the load balancer and maintain custom AWS WAF IP blocking rules. Option B. Subscribe to AWS Shield Advanced for the load balancer and engage the AWS Shield response team when assistance is required. Option C. Enable Amazon Inspector and ask its findings service to coordinate DDoS mitigation. Option D. Associate an AWS WAF Web ACL with the load balancer and manually block every previously unseen source address. The correct answer is B. Subscribe to AWS Shield Advanced for the load balancer and engage the AWS Shield response team when assistance is required. Here's why. Shield Advanced adds enhanced DDoS detection, mitigation, diagnostics, and expert response support for protected load balancers while requiring little architectural change. Why are the other options not correct? A. CloudFront and WAF can improve protection, but this option adds architecture and depends on maintaining custom source address rules. C. Amazon Inspector assesses software vulnerabilities and exposure. It does not provide managed DDoS response assistance. D. Continuously changing or spoofed source addresses make a manually maintained WAF allow or deny list ineffective for the stated attacks. Exam tip. Choose Shield Advanced when critical resources need enhanced DDoS visibility, cost protection, and expert response support. Question number 362. An existing AWS Snowball Edge customer has loaded 200 terabytes of seismic survey data onto storage-optimized devices for import into AWS. A cloud-based HPC fleet must process the imported dataset through a shared file system with consistent sub-millisecond latency and very high parallel throughput. Which design meets these requirements? Option A. Import the data into Amazon S3, copy every object into Amazon EFS, and mount EFS on the HPC instances. Option B. Import the data directly from the devices into a newly created Amazon FSx for Lustre file system. Option C. Import the data into Amazon S3 and expose the bucket through an AWS Storage Gateway file gateway to the HPC fleet. Option D. Import the data into Amazon S3, create an Amazon FSx for Lustre file system linked to the bucket, and mount the file system on the HPC instances. The correct answer is D. Import the data into Amazon S3, create an Amazon FSx for Lustre file system linked to the bucket, and mount the file system on the HPC instances. Here's why. Snowball Edge imports the dataset into S3. An S3-linked FSx for Lustre file system provides the parallel throughput and sub-millisecond file access required by the HPC workload. Why are the other options not correct? A. EFS provides shared NFS storage but is not optimized for this Lustre-style, massively parallel HPC access pattern. B. The Snowball import workflow delivers data to S3 rather than directly into an FSx for Lustre file system. C. File Gateway is designed for hybrid file access and does not provide the required HPC parallel file system performance. Exam tip. For imported S3 datasets that need HPC file performance, link Amazon FSx for Lustre to the S3 bucket. Question number 363. Several branch offices store small backup sets on on-premises NFS servers. The company needs a managed, scheduled process that periodically copies incremental changes to Amazon S3 without purchasing dedicated connectivity. Which solution is most cost-effective? Option A. Deploy an AWS DataSync agent near the NFS servers and schedule transfers to Amazon S3. Option B. Create an AWS Direct Connect connection and copy each backup through a private virtual interface. Option C. Use AWS Transfer Family to expose an SFTP endpoint and build a custom NFS to SFTP synchronization process. Option D. Run AWS Glue ETL jobs to read the NFS file systems and write the files to Amazon S3. The correct answer is A. Deploy an AWS DataSync agent near the NFS servers and schedule transfers to Amazon S3. Here's why. DataSync natively supports NFS sources, scheduled incremental transfers, encryption, and integrity checks without requiring a dedicated circuit or custom synchronization service. Why are the other options not correct? B. Direct Connect adds recurring cost and provisioning overhead that are unnecessary for small periodic transfers. C. Transfer Family provides managed protocol endpoints, but does not natively synchronize an NFS file system. D. AWS Glue is intended for data integration and ETL rather than file system backup transfers. Exam tip. Use DataSync for managed recurring transfers from NFS or SMB storage into AWS storage services. Question number 364. A competitive gaming platform runs match servers on Amazon EC2. The public endpoint must accept millions of UDP packets per second while adding as little latency as possible. Which architecture meets the requirement at the lowest cost? Option A. Deploy identical EC2 fleets in several regions and direct clients to every fleet without a load balancer. Option B. Place the game servers behind a gateway load balancer configured for the game ports. Option C. Create a network load balancer with UDP listeners and register the game server instances as targets. Option D. Create an application load balancer with listeners for the required UDP ports. The correct answer is C. Create a network load balancer with UDP listeners and register the game server instances as targets. Here's why. A network load balancer provides high-throughput, low-latency Layer 4 processing, supports UDP listeners, and scales to very large request volumes. Why are the other options not correct? A. Duplicating the complete fleet in multiple regions adds cost and does not itself provide the required UDP load balancing endpoint. B. Gateway load balancer is designed to insert and scale virtual network appliances, not game servers. D. Application load balancer supports HTTP and HTTPS application traffic, not UDP. Exam tip. Use a network load balancer for high-volume TCP, TLS, UDP, or TCP_UDP traffic. Question number 365. A healthcare application uses Amazon RDS for MySQL and is being migrated to an Aurora PostgreSQL cluster. The schema must be converted for the new engine, and changes made to the MySQL source during the migration must continue to reach the target until cutover. Which two actions satisfy the requirements? Choose two. Option A. Create an Aurora MySQL read replica of the source and promote it as an Aurora PostgreSQL cluster. Option B. Use AWS DMS schema conversion to convert compatible MySQL database objects for PostgreSQL. Option C. Create an Aurora PostgreSQL read replica directly from the RDS for MySQL instance and promote it after replication lag reaches 0. Option D. Use only a one-time native snapshot restore from MySQL into Aurora PostgreSQL. E. Create an AWS DMS full load and change data capture task from the MySQL source to Aurora PostgreSQL. The correct answer is B. Use AWS DMS schema conversion to convert compatible MySQL database objects for PostgreSQL. E. Create an AWS DMS full load and change data capture task from the MySQL source to Aurora PostgreSQL. Here's why. Schema conversion translates the heterogeneous database objects, while a DMS full load and CDC task copies existing data and continuously applies source changes until cutover. Why are the other options not correct? A. An Aurora MySQL replica does not perform the required cross-engine migration to PostgreSQL. C. Aurora PostgreSQL cannot be created as a native read replica of an RDS for MySQL instance. D. A one-time snapshot does not convert the engine or replicate ongoing changes. Exam tip. Use schema conversion plus DMS change data capture for low downtime heterogeneous database migrations. Question number 366. A streaming media website is exposed through an application load balancer. Security analysts need to investigate unusual client request patterns with standard SQL and do not want to operate an analytics cluster. Which solution is most operationally efficient? Option A. Query AWS CloudTrail records with Athena to identify every client request handled by the load balancer. Option B. Run a dedicated Amazon EMR cluster that queries the application load balancer directly. Option C. Enable application load balancer access logs to Amazon S3, define an Athena table, and query the logs. Option D. Download each load balancer access log object and search it manually with a text editor. The correct answer is C. Enable application load balancer access logs to Amazon S3, define an Athena table, and query the logs. Here's why. ALB access logs contain client and request details, and Athena performs serverless SQL analysis directly over the log objects stored in S3. Why are the other options not correct? A. CloudTrail records AWS API activity rather than the web requests processed by the load balancer. B. EMR adds cluster cost and cannot query an ALB directly for historical request logs. D. Manual file inspection is slow, difficult to scale, and operationally inefficient. Exam tip. Store ALB access logs in S3 and use Athena for low overhead request analysis. Question number 367. Workloads on EC2 instances in private IP version 4 subnets must initiate connections to Internet services while remaining unreachable from unsolicited Internet traffic. How should NAT gateways be deployed? Option A. Create public NAT gateways in public subnets in the same VPCs and route private subnet Internet traffic to them. Option B. Create private NAT gateways in public subnets and attach elastic IP addresses to them. Option C. Create public NAT gateways inside the private subnets that contain the EC2 instances. Option D. Create private NAT gateways inside the private subnets and route them to an Internet gateway. The correct answer is A. Create public NAT gateways in public subnets in the same VPCs and route private subnet Internet traffic to them. Here's why. A public NAT gateway resides in a public subnet, uses an elastic IP address, and reaches the Internet through an Internet gateway. Private subnets route outbound IP version 4 traffic to it. Why are the other options not correct? B. Private NAT gateways are intended for private network translation and do not provide public Internet access. C. A NAT gateway in a private subnet has no usable route through an Internet gateway. D. A private NAT gateway cannot provide Internet connectivity even if the VPC has an Internet gateway. Exam tip. Place public NAT gateways in public subnets and route private subnet IP version 4 egress through them. Question number 368. An AWS organization contains 3 sandbox accounts and 1 production account directly under the root. A service control policy denies launches of expensive EC2 instance types. The restriction must apply only to the sandbox accounts. Which 2 deployment approaches meet the requirement? Choose 2. Option A. Attach the SCP to the organization root. Option B. Attach the SCP to the organization's management account. Option C. Attach the SCP individually to each of the 3 sandbox member accounts. Option D. Create a sandbox OU, attach the SCP to that OU, and move the 3 sandbox accounts into it. E. Create a production OU, attach the SCP to that OU, and move only the production account into it. The correct answer is C. Attach the SCP individually to each of the 3 sandbox member accounts. D. Create a sandbox OU, attach the SCP to that OU, and move the 3 sandbox accounts into it. Here's why. Direct account attachment targets only the 3 sandbox accounts, while an OU provides scalable policy inheritance for the same accounts without affecting production. Why are the other options not correct? A. A root-level SCP would also restrict the production account. B. SCPs do not restrict the organization's management account. E. This approach applies the restriction to production rather than to the sandbox accounts. Exam tip. Attach an SCP to the narrowest accounts or OU that should inherit the guardrail. Question number 369. A retail platform uses a multi-availability zone Aurora PostgreSQL cluster. A campaign causes heavy read traffic, many new database connections, and application timeouts. The company needs additional read capacity and resilient connection handling with minimal downtime. Which solution is the best supported design? Option A. Enable zero downtime restart and database activity streams without adding database capacity. Option B. Add Aurora Reader instances, configure Amazon RDS proxy, send read traffic through a read-only proxy endpoint, and keep writes on the read/write endpoint. Option C. Capture Aurora state changes with EventBridge and invoke Lambda to record the events. Option D. Use AWS DMS to maintain a write-around RED-ISS copy of the Aurora database. The correct answer is B. Add Aurora Reader instances, configure Amazon RDS proxy, send read traffic through a read-only proxy endpoint, and keep writes on the read/write endpoint. Here's why. Provisionally, additional Aurora readers scale read workload and improve failover capacity. RDS proxy pools connections, while its read-only endpoint distributes read connections to the reader endpoint instead of the writer. Why are the other options not correct? A. Restart behavior and activity monitoring do not increase read capacity or manage connection surges. C. Event logging provides visibility, but does not scale the database or pool application connections. D. DMS is a migration and replication service, and the described RED-ISS pattern does not provide the required Aurora scaling design. Exam tip. For Aurora read scaling through RDS proxy, add readers and direct read-only connections to a read-only proxy endpoint. Question number 370. A VPC connects to corporate data centers through AWS site-to-site VPN. Applications in the VPC must resolve private service names that are authoritative on the corporate DNS servers. The records must not be published publicly. Which Route 53 design is most secure? Option A. Create a public hosted zone and publish records for the corporate services. Option B. Create a Route 53 resolver inbound endpoint and associate an inbound rule with the VPC. Option C. Create a Route 53 private hosted zone in the VPC and duplicate every record managed on premises. Option D. Create a Route 53 resolver outbound endpoint. Define forwarding rules for the corporate domains and associate the rules with the VPC. The correct answer is D. Create a Route 53 resolver outbound endpoint. Define forwarding rules for the corporate domains and associate the rules with the VPC. Here's why. An outbound resolver endpoint forwards selected DNS queries from the VPC across the VPN to the authoritative on-premises DNS servers without exposing the records publicly. Why are the other options not correct? A. A public hosted zone would expose private service names to public DNS resolution. B. An inbound endpoint allows on-premises clients to query DNS hosted in the VPC. It does not forward VPC queries to on-premises DNS. C. A private hosted zone would require duplicating records and would not query the existing on-premises authoritative servers. Exam tip. Use resolver outbound endpoints for VPC to on-premises DNS forwarding and inbound endpoints for the reverse direction. Question number 371. A global photography service stores uploaded images that are no larger than 20 megabytes. Some images stay popular for months, while others receive almost no views after several days. The application must quickly look up image metadata to decide what to display. Which design is most cost-effective? Option A. Store the images in DynamoDB and enable DynamoDB Accelerator for popular records. Option B. Store every image in S3 standard and transition all objects to S3 standard IA after exactly 30 days while keeping metadata only in object tags. Option C. Store images in S3 intelligent tiering and keep the image metadata and S3 object location in DynamoDB. Option D. Store the images in S3 Glacier flexible retrieval and keep metadata in Amazon OpenSearch service. The correct answer is C. Store images in S3 intelligent tiering and keep the image metadata and S3 object location in DynamoDB. Here's why. S3 intelligent tiering automatically adjusts storage cost as access patterns change, while DynamoDB provides scalable, low-latency metadata lookup and records each object's S3 location. Why are the other options not correct? A. DynamoDB items cannot contain 20 megabytes images, and DynamoDB is not cost-effective object storage. B. A fixed transition can move still popular images into a storage class with retrieval charges, and tags are not an ideal primary metadata database. D. Glacier storage does not provide the immediate interactive access required for all images. Exam tip. Use S3 intelligent tiering for objects with unpredictable access patterns and a purpose-built database for searchable metadata. Question number 372. An application load balancer distributes requests to EC2 targets whose processing times vary. Some targets accumulate many in-progress requests and become overloaded, while others remain lightly loaded. The company wants the load balancer to avoid sending new requests to busy targets. Which target group routing configuration should be used? Option A. Configure the least outstanding requests routing algorithm for the target group. Option B. Keep round-robin routing and shorten the target group health check interval. Option C. Configure weighted random routing without enabling anomaly mitigation. Option D. Keep round-robin routing and scale only from the total request count metric. The correct answer is A. Configure the least outstanding requests routing algorithm for the target group. Here's why. Least outstanding requests sends each new request to the target with the fewest requests currently in progress, reducing additional load on slower or already busy targets. Why are the other options not correct? B. Health check frequency changes failure detection, but does not make routing aware of outstanding request load. C. Weighted random can distribute according to weights, but without anomaly mitigation it does not directly choose the target with the fewest active requests. D. Round-robin can continue sending equal traffic to targets that are processing requests more slowly. Exam tip. Use least outstanding requests when target processing time or effective capacity varies. Question number 373. A company uses compute savings plans across EC2, Fargate, and Lambda workloads. The finance team wants an automated email alert whenever the percentage of eligible compute usage covered by savings plans falls below a target. Which solution has the least operational overhead? Option A. Create a daily AWS budgets report for savings plans and review it manually. Option B. Run a scheduled Lambda function that queries coverage data and sends messages through Amazon SES. Option C. Create a generic savings plans alert subscription and enable every available notification type. Option D. Create an AWS budgets savings plans coverage budget with a daily threshold and email notifications. The correct answer is D. Create an AWS budgets savings plans coverage budget with a daily threshold and email notifications. Here's why. AWS budgets natively monitors savings plans coverage and sends notifications when covered eligible usage drops below the configured percentage threshold. Why are the other options not correct? A. A scheduled report provides information, but does not directly alert only when coverage crosses the threshold. B. A custom Lambda and SES workflow duplicates a managed budget capability and requires code and maintenance. C. Savings plans does not provide the generic alert subscription feature described. Exam tip. Use savings plans coverage budgets to alert when eligible usage is no longer covered at the desired level. Question number 374. A provisioned Amazon MSK cluster spans 3 private subnets in an existing VPC. External Kafka clients must connect over the internet, and client-to-broker traffic must be encrypted and authenticated. The company wants to reuse the VPC and minimize additional infrastructure. Which design meets the requirement? Option A. Place an internet-facing application load balancer in front of the existing private brokers and use an HTTPS listener. Option B. Create public subnets in the existing VPC, deploy a replacement MSK cluster in those subnets, and enable public access, TLS encryption, and mutual TLS client authentication. Option C. Create a new VPC with public subnets and deploy a replacement MSK cluster with mutual TLS authentication. Option D. Place a network load balancer in private subnets and expose an HTTPS listener for Kafka clients. The correct answer is B. Create public subnets in the existing VPC, deploy a replacement MSK cluster in those subnets, and enable public access, TLS encryption, and mutual TLS client authentication. Here's why. Amazon MSK public access requires public cluster subnets, encrypted client broker traffic, and a supported authentication method such as mutual TLS. Deploying the replacement cluster in the existing VPC avoids creating another network environment. Why are the other options not correct? A. An application load balancer does not proxy the Kafka protocol to MSK brokers. C. A separate VPC and replacement cluster add migration and networking work when the existing VPC can be extended with public subnets. D. A private NLB with an HTTPS listener does not create the native public MSK broker endpoints required by the service. Exam tip. For public MSK access, use public associated subnets, TLS encryption, and a supported authentication mechanism. Question number 375. A distributor is replacing an hourly polling application that receives order files from an on-premises ERP system over SFTP. The AWS account already has private connectivity to the ERP network. The new service must be private, resilient across availability zones, store files durably, and invoke processing immediately after each upload. Which architecture meets the requirements? Option A. Deploy a VPC-hosted internal AWS transfer family SFTP endpoint across two availability zones. Use Amazon S3 storage and run a transfer family managed workflow that invokes Lambda after upload. Option B. Deploy an internet-facing transfer family endpoint in one availability zone. Use Amazon EFS and invoke Lambda from a managed workflow. Option C. Deploy an internal transfer family endpoint across two availability zones. Use EFS and run an hourly event bridge scheduler job that scans the file system. Option D. Deploy an internet-facing transfer family endpoint across two availability zones. Store files in S3 and invoke Lambda only from S3 event notifications. The correct answer is A. Deploy a VPC-hosted internal AWS transfer family SFTP endpoint across two availability zones. Use Amazon S3 storage and run a transfer family managed workflow that invokes Lambda after upload. Here's why. The internal VPC endpoint uses the existing private network path. Multi-availability zone deployment provides resilience. S3 supplies durable storage, and the managed workflow starts Lambda immediately after a successful upload. Why are the other options not correct? B. An internet-facing, single availability zone endpoint is less secure for the connected ERP system and does not meet the resilience requirement. C. Scheduled polling delays order processing and adds orchestration when transfer family can invoke a post-upload workflow directly. D. The internet-facing endpoint is unnecessary and exposes the service more broadly than required. Exam tip. Use a VPC-hosted transfer family endpoint and managed workflows for private, immediate post-upload processing. Question number 376. A research laboratory operates Hadoop and Spark clusters in its own facility. The current environment is difficult to scale and administer, but regulations require all processing to remain on premises. Which AWS architecture reduces cluster management effort while preserving local processing? Option A. Move the datasets to S3 with a Snowball device and run Amazon EMR in an AWS region. Option B. Use AWS DataSync to connect to HDFS and run the processing on a regional Amazon EMR cluster. Option C. Deploy AWS Outposts and run the Hadoop and Spark workloads on Amazon EMR clusters on Outposts. Option D. Connect the facility to a regional EMR cluster through site-to-site VPN and read the on-premises HDFS data remotely. The correct answer is C. Deploy AWS Outposts and run the Hadoop and Spark workloads on Amazon EMR clusters on Outposts. Here's why. Amazon EMR on AWS Outposts provides managed Hadoop and Spark clusters on AWS infrastructure installed on premises, satisfying data processing locality while reducing cluster operations. Why are the other options not correct? A. This moves data and processing into an AWS region, violating the on-premises processing requirement. B. Data sync transfers data. It does not keep the EMR compute workload on premises. D. A regional EMR cluster still performs the computation in AWS and adds network dependency for HDFS access. Exam tip. Use EMR on Outposts when managed big data processing must physically remain on premises. Question number 377. A design company is moving a large shared file repository to AWS. Windows, macOS, and Linux EC2 clients must access the same data through SMB and NFS. A small working set is active, while most blocks are rarely used. Which managed storage design has the least operational overhead? Option A. Use Amazon EFS with lifecycle management and expose it to all clients through native NFS and SMB. Option B. Use Amazon FSx for OpenZFS and configure native SMB and NFS access to the same file system. Option C. Store the repository in S3 intelligent tiering and use S3 File Gateway as the permanent file system service for all EC2 clients. Option D. Use Amazon FSx for NetApp on tap, create a data volume with the auto-tiering policy, and migrate the files to it. The correct answer is D. Use Amazon FSx for NetApp on tap, create a data volume with the auto-tiering policy, and migrate the files to it. Here's why. FSx for NetApp on tap provides managed multi-protocol access to the same data over SMB and NFS. Automatic tiering keeps active blocks on SSD and moves inactive blocks to the lower-cost capacity pool. Why are the other options not correct? A. EFS provides NFS access but does not offer native SMB access for the Windows clients. B. FSx for OpenZFS provides NFS but not the required native SMB multi-protocol access. C. S3 File Gateway can present file shares, but it is a hybrid gateway rather than the purpose-built managed multi-protocol file system described. Exam tip. Choose FSx for NetApp on tap when the same managed dataset needs both SMB and NFS access with storage tiering. Question number 378. An engineering report application is a tightly coupled monolith on one EC2 instance. Each report runs for about 20 minutes and must restart after an interruption. Frequent module changes cause full application downtime. The company wants gradual modernization, independent deployments, elastic scaling, and less downtime. Which solution best meets these goals? Option A. Keep the monolith in one elastic beanstalk environment and use all-at-once deployments. Option B. Separate the modules into microservices on Amazon ECS and use ECS service autoscaling with rolling deployments. Option C. Package the services on EC2 spot instances and accept interruption-driven report restarts. Option D. Move the entire 20-minute workflow into one Lambda function and reserve maximum provision concurrency. The correct answer is B. Separate the modules into microservices on Amazon ECS and use ECS service autoscaling with rolling deployments. Here's why. Containerized ECS microservices can be deployed and scaled independently. Rolling service deployments support gradual change and reduce downtime compared with replacing the entire monolith. Why are the other options not correct? A. All-at-once deployment keeps the monolithic architecture and causes complete environment interruption during changes. C. Spot interruptions can restart long-running reports and increase downtime. D. A single Lambda invocation cannot run for 20 minutes because it exceeds the maximum execution duration. Exam tip. Use independently deployable container services to modernize a monolith incrementally and reduce deployment impact. Question number 379. A Python web application currently runs on EC2. The team wants to extract one stateless component as a trial microservice. It must handle hundreds of requests per second, scale automatically, and require almost no server or cluster management. Which compute option is most appropriate? Option A. Run the component in a highly available elastic beanstalk web server environment. Option B. Deploy it to Amazon EKS with self-managed EC2 node groups. Option C. Implement the component as an AWS Lambda function using a supported Python runtime. Option D. Run it on an EC2 spot fleet with instance-based auto-scaling. The correct answer is C. Implement the component as an AWS Lambda function using a supported Python runtime. Here's why. Lambda supports Python, scales automatically with incoming requests, and removes server and cluster provisioning for the microservice experiment. Why are the other options not correct? A. Elastic Beanstalk reduces some administration but still provisions and operates server capacity. B. EKS with self-managed nodes introduces Kubernetes and EC2 administration that the trial does not require. D. A spot fleet requires instance lifecycle, patching, and scaling management and can be interrupted. Exam tip. Use Lambda for stateless, event-driven microservices that fit its runtime limits and need minimal infrastructure. Question number 380. A company has one AWS Direct Connect connection and 30 non-overlapping VPCs in a single region. Every VPC must communicate with the corporate network and with the other VPCs. The networking team wants centralized routing and a design that avoids managing separate private virtual interfaces for each VPC. Which architecture has the least operational overhead? Option A. Create an AWS Transit Gateway. Attach all VPCs. Associate a Direct Connect gateway with the Transit Gateway, and use a Transit virtual interface with route propagation. Option B. Create a Direct Connect gateway. Attach a separate virtual private gateway to every VPC, and rely on those gateways for transitive VPC routing. Option C. Build a transit VPC with routing appliances and create VPC peering connections between every remaining VPC. Option D. Create a separate site-to-site VPN from the data center to every VPC and operate both tunnels for each connection. The correct answer is A. Create an AWS Transit Gateway. Attach all VPCs. Associate a Direct Connect gateway with the Transit Gateway, and use a Transit virtual interface with route propagation. Here's why. Transit Gateway provides transitive, centralized routing among the VPCs. A Direct Connect gateway and Transit VIF extend the dedicated connection to the Transit Gateway without per VPC private VIFs. Why are the other options not correct? B. Virtual private gateways do not provide transitive routing between the VPCs and create per VPC administration. C. A transit VPC and extensive peering require appliances, many routes, and substantial management. D. 30 independent VPN connections duplicate the existing Direct Connect path and create high operational overhead. Exam tip. Use Transit Gateway with a Direct Connect gateway and Transit VIF to connect many VPCs to one dedicated circuit. Question number 381. A fleet of EC2 application servers uses IMDSV2, a current SSM agent, and an existing instance role to authenticate to Amazon RDS. The operations team must patch the servers with AWS Systems Manager without replacing that role or interrupting database access. The role does not grant Systems Manager permissions. Which solution meets the requirement? Option A. Create an IAM user with Amazon SSM Managed Instance Core and configure Systems Manager to use the user's access keys. Option B. Remove the database permissions from the current instance role and replace them with Amazon SSM Managed Instance Core. Option C. Attach a second instance profile containing Amazon SSM Managed Instance Core to every EC2 instance. Option D. Enable Systems Manager default host management configuration for the account and region. The correct answer is D. Enable Systems Manager default host management configuration for the account and region. Here's why. Default host management configuration supplies account-level systems manager permissions to eligible instances without replacing the existing application role that provides database access. Why are the other options not correct? A. Systems Manager does not manage EC2 instances by using an IAM user's long-term credentials. B. Removing the database permissions would disrupt the running application. C. An EC2 instance can have only one attached IAM role through its instance profile. Exam tip. Use default host management configuration when instances need Systems Manager access while retaining an existing application role. Question number 382. An Amazon EKS workload uses the horizontal pod autoscaler. During demand spikes, the autoscaler creates more pods, but some remain pending because every worker node is full. The company wants Kubernetes-aware node scaling without custom code. Which solution should be implemented? Option A. Scale the worker group only from average node memory utilization. Option B. Deploy Kubernetes cluster autoscaler to add nodes for unschedulable pods and remove underused nodes. Option C. Invoke a Lambda function whenever a pod becomes pending and resize the cluster from custom code. Option D. Use a generic EC2 autoscaling policy that is unaware of Kubernetes scheduling state. The correct answer is B. Deploy Kubernetes cluster autoscaler to add nodes for unschedulable pods and remove underused nodes. Here's why. Cluster autoscaler observes unschedulable pods and adjusts worker node capacity accordingly, complementing the horizontal pod autoscaler without a custom scaling service. Why are the other options not correct? A. Average memory alone does not reliably identify pods that cannot be scheduled because of cluster constraints. C. A Lambda-based controller duplicates Kubernetes scaling logic and adds code and maintenance. D. A generic EC2 policy does not directly react to Kubernetes scheduling requirements. Exam tip. Use HPA to scale pods and a Kubernetes-aware node autoscaler to scale worker capacity. Question number 383. A global mapping application maintains a stable 300 terabytes of 50 gigabytes objects in S3 standard. The application frequently replaces objects through multi-part uploads. Although the completed object count and total visible size remain constant, monthly S3 storage charges keep growing. What should a solutions architect configure? Option A. Enable S3 transfer acceleration instead of multi-part upload. Option B. Use CloudFront to reduce the number of objects retained in the bucket. Option C. Add an S3 lifecycle rule that aborts incomplete multi-part uploads after a defined number of days. Option D. Use S3 inventory to prevent objects from transitioning into archive storage. The correct answer is C. Add an S3 lifecycle rule that aborts incomplete multi-part uploads after a defined number of days. Here's why. Parts from incomplete multi-part uploads continue consuming S3 storage until the upload is completed or aborted. A lifecycle rule automatically removes stale uploaded parts. Why are the other options not correct? A. Transfer acceleration changes network routing, but does not delete incomplete multi-part upload parts. B. CloudFront caches delivered content and does not reduce hidden storage from incomplete uploads. D. S3 inventory reports object metadata and does not prevent or clean up incomplete multi-part uploads. Exam tip. Abort incomplete multi-part uploads with S3 lifecycle to prevent abandoned parts from accumulating storage charges. Question number 384. A ride-sharing game records rapidly changing latitude and longitude values for a growing number of players. An RDS for PostgreSQL database with read replicas cannot sustain the peak read and write rate. The application needs very low latency location updates and proximity lookups. Which change best improves the data tier? Option A. Add an Amazon Elastic Cache for RedISS cluster and use RedISS geospatial data structures for active location data. Option B. Restore the RDS database from a snapshot into a traditional multi-availability zone deployment. Option C. Place DynamoDB accelerator in front of the PostgreSQL database. Option D. Move the transactional location updates to Amazon OpenSearch Service and use OpenSearch dashboards. The correct answer is A. Add an Amazon Elastic Cache for RedISS cluster and use RedISS geospatial data structures for active location data. Here's why. RedISS provides very low latency reads and writes and native geospatial commands, allowing the application to absorb frequent location updates and queries outside the relational database. Why are the other options not correct? B. Multi-availability zone improves availability, but does not increase the database's read and write throughput for this access pattern. C. DAX is compatible only with DynamoDB and cannot accelerate an RDS for PostgreSQL database. D. OpenSearch is optimized for search and analytics rather than rapid transactional location updates. Exam tip. Use RedISS for rapidly changing, low-latency geospatial, session, or leaderboard data. Question number 385. An administrator accidentally deleted a production DynamoDB table and caused an outage. The company wants a managed control that prevents another table deletion rather than only restoring the table afterward. Which solution requires the least operational effort? Option A. Use CloudTrail, EventBridge, and Lambda to recreate a table after a delete table event. Option B. Enable point-in-time recovery on every table. Option C. Maintain a backup plan and restore deleted tables manually. Option D. Enable deletion protection on the production DynamoDB tables. The correct answer is D. Enable deletion protection on the production DynamoDB tables. Here's why. DynamoDB deletion protection blocks table deletion until the protection setting is intentionally disabled, directly preventing the accidental operation with minimal administration. Why are the other options not correct? A. This reactive workflow allows the outage to occur and requires custom restoration code. B. Point-in-time recovery supports restoration but does not prevent the table from being deleted. C. Backups enable recovery only after deletion and still involve disruption and manual work. Exam tip. Use deletion protection to block table deletion and point-in-time recovery to recover unwanted data changes. Question number 386. A factory is running out of local SAN capacity. It wants Amazon S3 to hold the primary block storage dataset, while keeping frequently accessed blocks on premises. Applications require immediate ISCSI access, and the design should minimize repeated WAN transfers and retrieval charges. Which architecture meets the requirements? Option A. Use S3 Glacier flexible retrieval with provisioned expedited retrieval capacity. Option B. Deploy AWS storage gateway in cached volume mode and size the local cache for the active working set. Option C. Deploy storage gateway in stored volume mode so the complete primary dataset remains on premises. Option D. Purchase Direct Connect and use stored volumes with asynchronous S3 snapshots. The correct answer is B. Deploy AWS storage gateway in cached volume mode and size the local cache for the active working set. Here's why. Cached volumes keep the primary data in S3 and retain frequently used blocks locally, reducing on-premises capacity and WAN reads while preserving immediate ISCSI access. Why are the other options not correct? A. Glacier retrieval is not immediate, and expedited or provisioned retrieval adds cost. C. Stored volumes require the full primary dataset to remain on premises and therefore do not solve the capacity shortage. D. Direct Connect adds cost, and stored volumes still require enough local capacity for the complete dataset. Exam tip. Use cached volumes when AWS should hold the primary data and the active block working set must remain local. Question number 387. An EC2 auto-scaling group supports an application whose demand follows daily and weekly patterns, but can also deviate from the forecast. The company wants capacity launched from learned historical trends and adjusted continuously when live utilization changes. Which scaling plan should be used? Option A. Use only step scaling based on average CPU utilization. Option B. Create fixed scheduled scaling actions from a manually maintained calendar. Option C. Combine predictive scaling with a target tracking dynamic scaling policy. Option D. Use simple scaling and increase the cooldown period to match instance startup time. The correct answer is C. Combine predictive scaling with a target tracking dynamic scaling policy. Here's why. Predictive scaling forecasts recurring workload patterns and provisions capacity in advance, while target tracking responds to real-time utilization that differs from the forecast. Why are the other options not correct? A. Step scaling is reactive and does not learn or forecast historical patterns. B. Scheduled actions require manual timing and do not continuously adapt as patterns change. D. Simple scaling with a longer cooldown provides neither forecasting nor responsive target tracking. Exam tip. Combine predictive scaling for expected demand with dynamic scaling for real-time deviations. Question number 388. A parcel tracking application uses EC2 and Aurora MySQL. The database load grows much faster than the application server load because clients repeatedly request the same delivery details. Adding one reader helped only briefly. Which solution reduces database work most cost-effectively? Option A. Cache frequently requested delivery details in Amazon Elastic Cache for RedISS and update the application to use the cache. Option B. Add another fixed Aurora reader instance. Option C. Enable Aurora auto-scaling for reader instances without changing the repeated query pattern. Option D. Configure multiple Aurora writer instances for the read-heavy workload. The correct answer is A. Cache frequently requested delivery details in Amazon Elastic Cache for RedISS and update the application to use the cache. Here's why. RedISS serves repeated results from memory, preventing duplicate queries from reaching Aurora and directly addressing the cause of the database load. Why are the other options not correct? B. Another reader adds temporary capacity, but the duplicate queries still consume database resources. C. Reader auto-scaling adds database capacity instead of eliminating repeated database work. D. Additional writer capacity does not address the repeated read statements. Exam tip. Cache repeated query results before continually adding relational read capacity. Question number 389. A reservation application reads from a DynamoDB table and sometimes receives older values after successful updates. Current latency is acceptable, and the application must return the latest committed table data. Which design change should be made? Option A. Create a global secondary index and query the index for every read. Option B. Request strongly consistent reads from the table for operations that require current data. Option C. Create customer-managed read replicas for the DynamoDB table. Option D. Explicitly request eventually consistent reads for all operations. The correct answer is B. Request strongly consistent reads from the table for operations that require current data. Here's why. A strongly consistent read from a DynamoDB table returns the result of the most recent successful write, trading additional read capacity cost for freshness. Why are the other options not correct? A. Global secondary indexes support only eventually consistent reads and therefore cannot guarantee the latest value. C. DynamoDB does not use customer-created read replicas for this purpose. D. Eventually consistent reads are the behavior that can return stale data. Exam tip. Use strongly consistent table reads when data freshness is more important than the lower cost of eventual consistency. Question number 390. An internet-facing application runs on EC2 and stores data in Amazon RDS. Database credentials already follow least privilege. The security team now wants managed protection against SQL injection, cross-site scripting, and similar malicious HTTP requests with minimal infrastructure administration. Which solution is most appropriate? Option A. Rely only on security groups and network ACLs around the web and database tiers. Option B. Deploy AWS network firewall and dedicated inspection subnets for every application request. Option C. Create additional database users and application code and assign each user narrower SQL privileges. Option D. Associate an AWS WAF Web ACL with the application's public HTTP entry point, enable appropriate managed rules, and retain suitable RDS security configuration. The correct answer is D. Associate an AWS WAF Web ACL with the application's public HTTP entry point, enable appropriate managed rules, and retain suitable RDS security configuration. Here's why. AWS WAF inspects Layer 7 web requests and provides managed and custom rules for SQL injection, cross-site scripting, and related attacks before requests reach the application and database. Why are the other options not correct? A. Security groups and network ACLs filter addresses, ports, and protocols, but do not inspect malicious HTTP payloads. B. Network firewall adds network infrastructure and is less direct than WAF for application layer web exploits. C. Database least privilege limits damage, but does not block hostile requests at the web boundary. Exam tip. Use AWS WAF at the public web layer for SQL injection and cross-site scripting protection. Question number 391. A healthcare platform operates Aurora Postgres QL clusters in several member accounts of an AWS organization. The security team wants a managed service to detect unusual database authentication behavior, including anomalous failed and incomplete login attempts, without building a centralized log analysis pipeline. Which solution will meet these requirements with the least operational effort? Option A. Send AWS CloudTrail records for all database-related API activity to a central Amazon S3 bucket. Option B. Apply service control policies, SCPs, at the organization root to identify suspicious database logins. Option C. Enable Amazon GuardDuty RDS protection for the organization member accounts that host the databases. Option D. Publish Aurora Postgres QL logs to Amazon CloudWatch logs and create custom queries and alarms for failed logins. The correct answer is C. Enable Amazon GuardDuty RDS protection for the organization member accounts that host the databases. Here's why. GuardDuty RDS protection analyzes supported Postgres QL authentication activity and creates findings for anomalous successful, failed, and incomplete login attempts without a custom detection pipeline. Why are the other options not correct? A. CloudTrail records AWS API calls, not the database engine authentication activity required here. B. SCPs define permission guardrails and do not inspect or detect database login behavior. D. Log collection and custom alarms can work, but require more configuration and ongoing maintenance. Exam tip. Use GuardDuty RDS protection for managed detection of anomalous authentication activity in supported RDS and Aurora Postgres QL databases. Question number 392. A manufacturing group has one data center connected to AWS through Direct Connect in North America and another data center connected through Direct Connect in Europe. The group also has non-overlapping VPCs in both regions. Each data center must privately reach every VPC, and the network team wants a scalable design that avoids managing a mesh of tunnels and per VPC circuits. Which architecture should a solutions architect recommend? Option A. Associate the private virtual interfaces from both Direct Connect connections with a Direct Connect gateway, and associate the virtual private gateways for the regional VPCs with that gateway. Option B. Create inter-region VPC peering connections between the North American VPC and every European VPC. Option C. Create a separate private virtual interface from each Direct Connect connection for every destination VPC. Option D. Deploy VPN appliances on Amazon EC2 and build a full mesh that uses AWS VPN Cloud Hub for all sites and VPCs. The correct answer is A. Associate the private virtual interfaces from both Direct Connect connections with a Direct Connect gateway, and associate the virtual private gateways for the regional VPCs with that gateway. Here's why. A Direct Connect gateway lets private VIFs reach virtual private gateways attached to non-overlapping VPCs in multiple regions, centralizing the hybrid connectivity design with less administration. Why are the other options not correct? B. VPC peering connects VPCs, but does not extend Direct Connect connectivity transitively to the data centers. C. Creating separate VIFs for each VPC increases configuration effort and does not provide a centralized scalable design. D. A full mesh of EC2-based VP and appliances adds tunnels, routing, scaling, and appliance maintenance. Exam tip. Use a direct connect gateway to extend private VIF connectivity to non-overlapping VPCs across multiple AWS regions. Question number 393. A ride-sharing application sends vehicle position events to a backend during peak commuting periods. Events for each vehicle must be processed in the order received. Traffic can spike sharply, and process state must be stored in a highly available database. The company prefers managed services and does not want to operate consumer servers. Which solution best satisfies these requirements? Option A. Publish events to an Amazon SNS topic, invoke AWS Lambda, and store the results in a relational database hosted on Amazon EC2. Option B. Write events to Amazon Kinesis data streams, process them with an auto-scaling fleet of EC2 instances, and load the results into Amazon Redshift. Option C. Place events in an Amazon SQS standard queue, process them with an EC2 auto-scaling group, and store the results in an Amazon RDS multi-availability zone database. Option D. Write events to Amazon Kinesis data streams using a vehicle ID as the partition key, process them with AWS Lambda, and store the results in Amazon DynamoDB. The correct answer is D. Write events to Amazon Kinesis data streams using a vehicle ID as the partition key, process them with AWS Lambda, and store the results in Amazon DynamoDB. Here's why. Kinesis absorbs bursts and preserves order within a shard when related events use the same partition key. Lambda removes server management, and DynamoDB provides managed highly available storage. Why are the other options not correct? A. SNS does not provide ordered processing for this workflow, and a database on EC2 adds administration. B. EC2 consumers and Redshift add operational overhead and are not a good fit for low-latency operational state. C. An SQS standard queue does not guarantee ordering, and EC2 workers require capacity management. Exam tip. Use a consistent Kinesis partition key when records for the same entity must remain ordered. Question number 394. A software company stores audit files in S3 buckets owned by multiple AWS accounts. All buckets are in EU Central 1. The analytics team needs every new audit object copied into one central bucket in the same region, with minimal code, administration, and cost. Which solution is most appropriate? Option A. Configure cross-account S3 same region replication from each source bucket to the centralized bucket in EU Central 1. Option B. Invoke an AWS Lambda function for every S3 object created event and have the function copy each object to the centralized bucket. Option C. Create S3 lifecycle rules in the source buckets to copy audit objects into the centralized bucket. Option D. Run a daily script that lists every source bucket and uses putObject to recopy the contents into the centralized bucket. The correct answer is A. Configure cross-account S3 same region replication from each source bucket to the centralized bucket in EU Central 1. Here's why. Same region replication automatically copies new objects across accounts to the destination bucket, while keeping the data in the required region and avoiding custom copy code. Why are the other options not correct? B. Event-driven Lambda copies can work, but introduce code, retries, permissions, and operational maintenance. C. Lifecycle rules transition or expire objects. They do not copy objects to another bucket. D. A daily full copy script is inefficient and requires scheduling, deduplication, retries, and maintenance. Exam tip. Use S3 same region replication to consolidate objects in one region without a custom replication process. You have completed part 11 of the SAA-C03 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.